Alright, today we're going to do stoichiometry, worksheet 2, grams, liters, and molecules. Now, remember when we do this, we have to use our the concept of we have moles to moles ratios, right? Moles of our starting substance over here, and we're going to moles of our ending substance over here. And to be able to do that, we have to cross this line and go from moles of one thing to moles of another. Now, that was the part we did in worksheet number 1. Now, for worksheet number 2, what we're going to do is we're going to add the fact that we could start in grams or liters or molecules. Now, we have to be able to convert from grams to moles, liters to moles, or molecules to moles before we do our one-step conversion going across this wall. Again, that was worksheet 1. And then we can go back to, again, what we did last unit where we convert from moles to grams, moles to liters, or moles to molecules. All right, let's go ahead and give this a shot and see what happens. How many liters of carbon dioxide gas are formed? Liters of carbon dioxide gas are formed when 44 moles of CH4 is burned. That's methane gas. So I need to start with CH4, and it's burned, so it's burned in oxygen, and it produces carbon dioxide, and it produces water. Now I have one carbon on the left, one carbon on the right. 4 hydrogens on the left, only 2 on the right. So I have to put a 2 in front of that, which means I have 4 oxygens, which means I have 2 O2s. So there's my balanced chemical reaction. And I'm using 44 moles of CH4, and I'm asking how many liters of carbon dioxide there are. Let's do that, question mark, liters, right? So this means I have to go from moles of CH4 to moles of CO2, and then go to liters of CO2. Again, think about your chart of what you have to do. All right. So I have 44 moles of CH4. Now you'll notice I write out the entire unit because it's important, because I have to get rid of moles of CH4. It's too easy to get confused here. And I want to go from moles of CH4 to moles of CO2. But I don't want moles of CO2, I want liters of CO2, so I have to get rid of moles of CO2 and go to liters of CO2. Now, some of these are easy. I always know that there are 22.4 liters in 1 mole of any gas at standard temperature and pressure. And I look at my coefficients from methane gas, to carbon dioxide, and it's a 1-to-1 relationship. So I simply multiply the 44 times the 22.4, and that gives me 990 liters of CO2. Now, you'll say, wait a minute, how come it's only 990? That isn't what my calculator told me. Well, you're right, but you can only have 2 digits of precision in your answer because you only have 2 sig figs in your question. So that is, in fact, the correct answer. Okay, how about number 2? We're forming barium sulfate, 43.5 grams of barium sulfate, so that's important. And they're formed when we react barium nitrate and sodium sulfate. How many moles of sodium sulfate, that's the other piece of information I want to figure out, moles of sodium sulfate are reacted? I don't know. Let's go figure it out. So let's start with barium nitrate. Barium nitrate. And barium nitrate is +2, nitrate's -1, so it's BaNO3 plus sodium sulfate. Sodium sulfate is NaSO4. Again, +1 -2 means I have to have a 2 after the sodium. Gives me, well, that's going to give me sodium nitrate, NaNO3, sorry about that, NaNO3, plus barium sulfate, BaSO4. All right, and that's +1 -1, +2 -2, so that balances, but now I have to balance my equation, and I realize I need 2 sodiums and 2 nitrates on the right. The barium sulfate is going to be a solid. Everything else is going to be aqueous. If you want to bother looking that up, you can figure that out. Right? Now, the problem is I'm starting with 43.5 grams of barium sulfate. That's what I'm producing. Sorry, 43.5 grams of barium sulfate. And it's asking me how many moles of sodium sulfate, number of moles of sodium sulfate are required. Okay. Well, my problem here is I have to go and figure out how much barium sulfate weighs, or else I can't do this problem. So if I figure out barium sulfate, right, I'm going to figure out that barium sulfate weighs. I'm going to let you do that on your own. I'm not going to waste your time here. I assume you can figure out that it weighs 233.39 grams per mole. So that allows me to do my problem now. So I start with 43.5 grams of barium sulfate. And I want to convert from grams of barium sulfate to moles of barium sulfate. I always want to go to moles. Remember, moles always has to be in the middle. Right? Well, I don't want moles of barium sulfate. If I look at what the question is asking me for, it's asking me for moles of sodium sulfate. So I can go from moles of barium sulfate to moles of sodium sulfate, and then I'm done. Well, let's look at what information I have. 1 mole of barium sulfate weighs 233.39 grams. And barium sulfate has a 1 in front of it, implied. And sodium sulfate has barium sulfate's over here. Has a 1 in front of it, and sodium sulfate has a 1 in front of it, so they're both 1s. So I put a 1 and a 1 there. And when I do the math of 43.5 divided by 233, everything else is 1, so I get 0.186 moles of sodium sulfate. That's my final answer. Realize three sig figs in my question, 3 sig figs in my answer. All right. I have 32.3 liters of oxygen, and they're formed when KClO3 is decomposed. How many moles of KClO3 reacted originally? So I've got liters over here, I've got moles, and I look at this and I have to have a 2 there, I have to have a 3 there, I have to have a 2 there to balance everything. All right, so that's my balanced chemical equation. And I have liters, I have moles, so I don't have to calculate grams for anything. So I start with 32.3 liters of O2. Now, what do I go to from liters? Well, I always go to moles. So I can go from liters of O2 to moles of O2. But I don't want moles of O2. It's asking me for moles of potassium chlorate. So I have to go from moles of O2 to moles of potassium chlorate. And then I'm done. So let's see, what are my conversion factors? Well, 1 mole of oxygen is 22.4 liters at STP. What about 1 mole of, how many moles of oxygen, that's a 3, relate to my potassium chlorate, which is a 2. So 3 moles of oxygen give me 2 moles of potassium chlorate. So once I set this up and do all the math, I get 0.961 moles of KClO3, potassium chlorate. All right, let's do a couple more before we take a break. We have 22.8 grams of sodium hydroxide, so I have to figure out how much sodium hydroxide weighs. And if you go and do that, calculate that, I'm sure you can do that. That weighs 39.997 grams per mole. And I'm asking for grams of water, and grams of water are 18.015 grams in 1 mole of water. So you have to figure that out before you can even do the problem. Right? So we also have to come up with the balanced chemical equation. So we have sodium hydroxide plus hydrochloric acid, which is HCl, gives me water, and the other thing that's left is NaCl. Table salt. So it gives me salt water. Now I look at my equation. My equation is balanced. So there's nothing I have to do to balance it. So I start with 22.8 grams of NaOH. Now I want to go from grams of NaOH to water. So I have to go from grams of NaOH to moles of NaOH. Remember, I always go to moles in the middle. Grams of NaOH to moles of NaOH. Notice I'm not writing numbers, I'm just writing units. And then I go from moles of NaOH to moles of water. But I don't want moles of water. I want grams of water. And now I'm at my final units, so that's great. So now I can go and put in some numbers. 1 mole of NaOH weighs 39.997 grams. And 1 mole of water weighs 18.015 grams. And what's my relationship between sodium hydroxide and water? Well, it looks like it's a 1-to-1 relationship. Okay, so that's real nice and easy. So now if I sit down and I do all this math and work it out, I'm going to come out with 10.3 grams of water. Remember, you're multiplying everything on the top, dividing by everything on the bottom. All right, last one for this page. This is 32.5 grams of iron chloride. Ooh, that's going to be a good one. Iron 3 chloride are reacted with silver nitrate. How many grams of silver chloride are formed? All right, so we have some clues as to our balanced chemical reaction. So we're reacting iron 3 chloride, so that's FeCl3. And they're reacting with silver nitrate, which is AgNO3. And we're producing silver chloride, which is AgCl. Plus we're producing iron 3 nitrate. So I have to have 3 of those. Okay, well, if I've got 3 of those, I have to have 3 of these, which means I have to have 3 of those, which gives me 3 chlorines, 1 iron. I am now balanced. Okay, so let's go and do this. Grams of iron chloride. We have to figure out how much iron chloride weighs. Well, iron 3 chloride, which is FeCl3, if I do the math, will end up being 162.206 grams per mole. And how about silver nitrate? Let's see, silver chloride is what I care about down here. That's AgCl, and AgCl is 143.32 grams. I'm not going to waste your time doing this here. If you don't know how to do it, please see me in class or see Miss Sherman, right, so that we can go and fix that. But you should already know how to do that. That's old stuff. All right, so let's go ahead and work through our problem. We have 32.5 grams of iron 3 chloride. Now, for me to work through my problem, I have to go from grams of iron 3 chloride to moles of iron 3 chloride, and then moles of iron 3 chloride to moles of silver chloride, and then moles of silver chloride to grams. Grams of FeCl3. And I can go to moles of FeCl3. FeCl3. And then I can go from moles of FeCl3, and I'm going to moles of my target, which is silver chloride, which is AgCl. And then from moles of AgCl, I'm then going to grams, because it's asking me for grams of silver chloride. So those are the pieces I have to do. Now, what are my conversion factors? Well, 1 mole of FeCl3 we figured out weighs 162.206 grams. And if we look at our coefficients on FeCl3, that's 1, and on AgCl, that's 3, so we have a 1-to-3 relationship here. And 1 mole of AgCl we figured out weighs 143.32 grams. So if I do all of my math, multiply by the ones on top, divide by the ones on the bottom, I end up with 86.1 grams of AgCl. And that's your final answer. All right, guys, what we're going to do is take a break, because our podcasts are getting rather long. So take a break, get a drink of water, whatever, come back, and we'll do the last 6 on the other side of the next piece of paper. Okay? Thanks. See you soon. Bye.